In this video, we'll show you how to connect a scanner to Hyper and use it in your projects. We have a tool that both paints and has a scanner attached to it. The project's principle is simple. The scanner scans the part, Hyper calculates the trajectory, the scanner sends the robot to execute, the operator changes the part's position, and Hyper recalculates. The scanner is positioned above us, and the part is just a test box. First, we need to create a project for ENCY. Add an operation. Set the tool's position, and calculate the trajectory. Done. The trajectory is calculated, and it looks good. We can change the parameters, for example, adjust the step. Let's recalculate. Great. Now let's save the project. After saving the project, we can export the operation parameters. Next, we need to launch the operation parameter editing utility and select the parameters that will be visible to the Hyper operators. We launched the utility and specified the parameter file. Here we see a large number of operation parameters. We can see almost all of them and choose the ones we need to display in the Hyper user interface. Let's select the step. The most important thing is not to forget to save the parameter file. Next, we'll open the cell file in Hyper. It looks like this. The cell is quite simple. It's a robot with a pedestal for parts. Let's open this cell in Hyper and set the scanning program. We'll set 5 key scanning points. Depending on your scanner, you can set more points or stick to just one. The first scanning point will be like this, where the scanner looks at the part from above. For convenience, let's save this robot position and call it Scan Position. We'll set the second scanning position, moving the tool along the y-axis. And save this position. Let's add a new scanning position. And also, save it. Let's add a third scanning position, select the very first position, and move the tool along another axis. We'll also save it and set the last scanning position. Great. Let's save the last position. Now we have a trajectory passing through several key points, and at the end, we'll return to scan position. Let's edit our program. Right now, it's clear that the robot goes through all the points, but that's not what we need. We probably don't need the first position. The robot should move to this position with linear motion. Let's add a new block. After moving to the second scanning position, the robot will go to the center of scanning. After which it will move linearly to the last scanning point and return to the center. The robot moves linearly to the center and makes one more move. Great. Let's group these commands and call them the scanning program. Let's calculate. Perfect. Next, we need to configure the scanning utility. Here, we set the 3D model of the reference, connect to the scanner, and see what the scanner sees. We see the image from the camera and the point cloud that the scanner identified. The point cloud corresponds to the table on which the box is placed. Let's set the boundaries of the working area to cut off unnecessary points. We're using a not very good scanner, so the scanning quality is mediocre. With more expensive scanner models, you'll get much better results, but Hyper works even with such data quality. Even with such low scanning quality. Let's cut off unnecessary points from above and below. We're cutting off the points of the table because our part is flat, and the system will find it hard to determine the part's position on the table. Given the low quality of the points from the scanner. To bypass this limitation and get better results, we'll cut off all points belonging to the table, to only get points belonging to the part. You can set precise values. I think we need to raise the cutting plane a bit. Yes, that's much better. We have a lot of different parameters. We can check the scanning quality, change the resolution, and simplify surfaces. All these settings are specific to our Intel scanner, but your scanner may have different parameters that you can include in the driver. It's clear that we can scan, get new data, and we definitely need to save the settings. That's enough. Let's return to Hyper. Check that we have the correct paths set to the CAM system and import the NT project. The NT project has been imported. We see the trajectory that was calculated in NT. Our scanning program is running, and then comes the processing. This is the processing of the ideal part as it was calculated in NT. Great. Now we need to connect the scanner to Hyper. Let's go to the Extensions section and specify the path to the scanning utility. We're using Intel, so we have the path to the Intel Scanner utility. This is our utility. We wrote it. The button to turn the scanner on and off has appeared. Let's turn on the scanner. In the operation, you can click the Update Part button. The scanning of the part is executed. We got the image. We got the point cloud, and the algorithm determines the position of the 3D model in this point cloud. A very important point, we need to recalculate the trajectory after we updated the part's position. It's clear that the model's position has changed, and the trajectory has changed. Let's run it in Run Mod mode. Scanning is taking place, the utility is launched, the utility has received the part's position. Recalculated the trajectory, and waits 15 seconds while the operator checks if everything is correct. Remove the 15-second wait since we don't have a real robot. This is just a simulation. In real production, of course, you need to give the operator a chance to check that the scanner didn't make a mistake. Scanning is taking place. We saw the part's position, got the point cloud, determined the position of the reference part in this point cloud, and recalculated the project. Now the robot no longer waits for the operator's confirmation. It immediately goes to process. We're changing the part's position. The robot executes the scanning program, analyzes the obtained point cloud. Determines part position, gets a new trajectory, and executes it immediately. Another iteration, scanning, obtaining the point cloud. Determining the part's position, recalculating the trajectory, and immediate execution. Thus, we have created a fully automated system for processing parts. The operator just needs to place the workpieces on the table. The robot will carry out the scanning procedure. Determine the part's position and immediately start processing the actual part considering its real position on the table. The system is universal. It will work with any scanner. All we need from the scanner is to get a point cloud. Next, we either convert this point cloud to the STL format for mesh processing, or use the reference 3D model to determine its position and update it in the Hyper project. We have two modes of operation. Either we use raw data from the scanner, converting it to a mesh, or we convert it ourselves. So you just need to use any scanner that can output a point cloud. In fact, almost all scanners can output a point cloud as a result of their work. Everything else will be handled by Hyper. Editor M.